part 2, we're going to specifically look at the reciprocal trigonometric equations. That means we're going to consider the following 3 scenarios. We're going to look at the case when secant theta is equal to some value. We'll look at the case when cosecant is equal to some value. And we'll look at the case when cotangent is equal to some value. So we would like to develop a procedure to solve these kinds of trigonometric equations. What you're going to find as I'm working through a couple examples with you is that the procedure for the reciprocal trig equations are almost identical to our regular trig equations. I just add in this extra first step where I convert the reciprocal trig function to one of our usual 3 that we work with more often, sine, cosine, or tan. After you've converted your reciprocal trig function to sine, cosine, or tangent, then you can use the cast rule to determine which quadrants you want, solve it on 0 to 2 pi, for example, and then apply your periodic solution if you have to. First, we're going to solve the trigonometric equation cosecant of theta is equal to 2. And we're going to solve it on the interval from negative pi to positive pi. Now what I tend to do first is I tend to change this reciprocal function into a usual trig function. We know that cosecant of theta is 1 over sine of theta. Next, since we have sine of theta in the denominator, we can multiply both sides by sine theta to get 1 is equal to 2 sine of theta. And then we can divide both sides by 2 to get sine theta is equal to 1/2. So I'm just going to rewrite that so that sine theta comes first. And now, instead of solving cosecant of theta is equal to 2, now we can think about our usual trigonometric function sine instead. Just like we did before, we're going to use the cast rule to determine which quadrants we're going to be solving in. We have that sine of theta is positive, so that's going to rule out this quadrant as well as this quadrant. So we're going to be solving for sine in these 2 quadrants here, the first one and the second one. So let's go ahead and draw some right-angled triangles in. And we have our 2 values, our 2 reference angles, theta, down here. Now sine theta is opposite over hypotenuse. So opposite is going to be 1 and the hypotenuse is going to be 2. So in this case we have a 1, 2, root 3 triangle. Since our reference angle theta is across from the smaller of the side lengths, it must be that theta is equal to 30 degrees, or theta is pi by 6. So pi by 6 is going to be one of the angles that we're looking for. The other one that we're looking for begins at 0 and goes all the way over here. This is 6 pi by 6 minus pi by 6. So our other value for theta is going to be 5 pi by 6. So our 2 solutions on the interval from negative pi to positive pi are pi by 6 and 5 pi by 6. Next up, let's try to determine when secant of theta is equal to negative root 2. We know that secant is the reciprocal function of the cosine function, so I'm going to replace secant with 1 over cosine. Then I can multiply both sides by cosine of theta. And finally, I'll divide both sides by the square root of 2. And I'm just going to flip the order so that cosine is first. So we know here that cosine of theta is going to be equal to negative 1 over root 2. Or we could alternatively think about this as negative root 2 over 2. So here's a moment where I can explain to you why I care about the 2 different notations here for cosine of theta. Why do I care that negative 1 over root 2 is the same thing as negative root 2 over 2? Well, it turns out that the first expression that we have, negative 1 over square root of 2, is more advantageous for us to use if we want to work with the 2 special triangles. It also turns out that negative root 2 over 2 is more advantageous to us if we want to use the unit circle. Since I tend to work with the two special triangles, I'm going to favor having cos theta in this form, negative 1 over square root of 2. So let's go ahead and set up our cast rule. We have that cosine is negative. So here cosine is positive, here cosine is positive, so our two quadrants of interest are here and here. So let's go ahead and put in our right angled triangles and our reference angles theta. And I know that cosine is adjacent over hypotenuse. So our hypotenuse here is going to be square root of 2, and our adjacent side is going to be negative 1. This is a 1, 1, root 2 triangle. So that means that our reference angle here is pi by 4. So let's use our reference angle to figure out these two angles on 0 to 2 pi. So our first angle of interest is this one here. This is 4 pi by 4 minus 1 pi by 4. So that is 3 pi by 4. And then our second angle of interest is this one here that starts at 0 and goes all the way down to here. That's going to be 4 pi by 4 plus 1 pi by 4. And so that angle is 5 pi by 4. So on our restricted domain, 0 to 2 pi, we have that theta is equal to either 3 pi by 4 or 5 pi by 4. And finally, we know that cosine of theta is going to repeat every 2 pi radians. So all solutions are going to be given by the following. Theta is equal to 3 pi by 4 plus 2n pi, and theta is also equal to 5 pi by 4 plus 2n pi. And of course, n here is any integer value. All right, my little epsilons, stay positive.